Let's discuss the basics of gravitation. When I ask my students what is gravitation, they generally say that it is a force for which anything falls towards the surface of the earth. Well, it is not about the surface of the earth what Newton stated. He stated something much more beyond the earth. What he observed. Yes, he observed an apple. So let's select the apple. Let's select this apple. Like what Newton observed. He observed the apple to fall to the ground. That is what he observed. But what he concluded is something really extraordinary. He stated that every particle attracts every other particle in the universe. Take a note, every particle attracts the other in the universe, not about the earth. With a force, so if I call it a force, let's call that force to be F suffix G. So this is the force of the gravity, and this is directly proportional to the product of the masses. So if one has mass m1, the other one to be m2, so it's directly proportional to the product of these two masses, and again is inversely proportional to the distance square. So I call this one to be the mass m1 and this one to be m2. m1 and m2 are the masses wherever they are in the universe, and they have a separation. Okay, let's call this separation. They have a separation of a distance. Let's call that a distance of r. So this is r. R is the distance between these two masses. Now let's have an analogy that if there are two magnets, say one magnet being, let's call that to be m1, the other one to be m2. If m1 is greater, then the force of attraction is, if f1 is greater, then the force of attraction will be more. If m2 is greater, then the force of attraction will again be more. So force increases if either of the masses or either of the magnetic force, whatever we call, is more. Now if we put these two magnets closer, if two magnets are closer, then the force of attraction will be more or less. It is going to be more if the distance is less, and if the distance is far away, then the distance increases but the force decreases. So that is why this is inversely proportional, and it is exactly inversely proportional to the square of this. Though I understand that the force is proportional to the product of the masses, is inversely proportional to the square of the distance. So I club these together. The force is proportional to the mass, product of the mass, and inversely proportional to the square. Now this force is proportional to these parameters. What will this force be exactly equal to then? To understand this, we need to have a clear concept of what is proportionality constant. What is proportionality constant? Let's have two parameters. I call one parameter to be A and the other one to be B. And when A is 1, B is 3. When A is 3, B is 9. When A is say 10, B is 30. I can see that whenever A increases, B also increases. So that means A is proportional to B. Or I can say B is proportional to A. A is proportional to B, B is proportional to A. That gives a good intuition that one follows the other. But science doesn't only depend on intuitions. We quantify things in science. What is exactly B equal to what times of A? In this example, I have taken that B to be exactly 3 times of A. So whenever A is 1, I get B equals to 3. Whenever A is 10, I get B as 30. So this parameter which helps us to get the direct relation between two is the proportionality constant, where this proportionality constant, here I can find B by A. So in the same way, in the same manner, I will again have this force due to gravity B equal to m1 m2 by r square multiplied by the proportionality constant for this, and I call it this to be G. G is the proportionality constant of this expression, which makes the right hand side equal to the left hand side, where G is equal to 6.674 times 10 power minus 11 meter cube per kg per second square. But wait, meter cube per kg per second square, how do I even remember this sort of complicated stuff? I don't have to remember actually. If F is equal to G times m1 m2 by r square, then I need to figure out this G, unit of G, then has to be equal to F times r square by m1 m2. And I know what is r. R is the distance, so distance means length square, mass, these are the masses, I can call it kg, so it's kg into kg, kg square. And force, what will be force? Again, force, I know force is equals to mass times acceleration. Mass means kg, acceleration is length per second square. I can directly put kg, there's one length and one per second square. Kg is power minus 1, length and length square gives length cube, and per second square I get, so it's kg, it's per kg, length is meter cube per second square. So this is what we get here. So given this, you can find the force of attraction of any object throughout the universe. If any object is there in the universe and you need to find what is the force with which you are attracting that object, or that object is attracting you, you just ask for what is the mass of that object and how far is the object from you, and you can directly find with what force is that object attracting you, or you are attracting that object. So this is all about the basics of gravitation. In the next lecture, we'll discuss about the gravity of Earth.